freaking 7 people here.
Nobody watches
Bookclub's getting out of hand.
I watch it.
Alright,
I'm gonna be so offended.
Nobody
First order of Book
watches
Club
it,
is
so
how do we
nobody will
remove
report
members
it.
from Book Club? This is just getting out of
I'll
hand,
report
and
it.
we need to cleanse.
That's offensive, Tyler.
Guys, I have the conch.
That was uncalled.
I'm not here.
Why can't I log into Magic Online? What is going on?
Why are you going on Magic Online?
Because I want to play
Can
Magic
you like
while we do
stream
this.
to us?
I'm gonna defend the
Are
fox
you
while I
kidding
do
me?
it.
Why don't you play Smile when we do this? Just mute your mic. Or just don't
There's
talk about
no
the game.
way we could focus.
I could maybe do it, but we can't talk about the game.
Yeah, that's fine.
I guess I'll mute Joe and Ethan just to be
Don't
safe.
mute me! Don't you fucking dare!
So
Hold on. I for some reason can't log into Magic Online.
no, it's okay. Are you gonna be streaming it so we can
tabs.
watch it?
So if you want me to stream it, we'll have to get into a call and not just a voice chat.
Oh, I see. Well, that's
So
fine.
I
Never mind.
can. We just have to do this. Let's see. I'll call Mitch first.
Hello?
Lane. Joe. Tyler. Is that everybody?
Jesus.
Did I forget anybody?
Hi, it's me.
Hello?
Hello?
Is this
Hello?
everybody? Is this everybody for the book club?
This is the
I
book
see
club.
Lane, I see Austin, and I see Mitch, and I don't see Tyler.
I see Tyler.
Tyler?
I'm here. I just can't tell where this came from.
Oh,
I
I don't
called you on Discord directly.
see.
Oh, here we go.
How do I just see your screen only, Austin?
Can you click it?
No.
You should be.
I see everybody's screens, but
Like if-
I just want to see yours.
Like double click my screen.
Oh, cool. Neat.
Okay. Now we can talk about book club.
What do you guys think of book club?
I was super confused by this chapter.
Yeah.
Well,
I love this chapter.
This chapter was pretty straightforward, just defining initial and final.
Yeah.
Objects.
Yeah.
Is object the right word?
Yep.
I'm,
Initial and final objects.
Not gonna lie, I read this like in between
Like 30
grading
minutes ago?
in between grading papers,
That's fair.
and I had to reread the initial and final definitions like 3 times
Mhm.
I had to
because
read.
this is the same thing.
Yeah, I was okay with the definitions, and I could understand it when it was referring to like the greater than or equal to stuff.
Yeah.
But it
Yeah,
was really
yeah.
difficult to understand when it was just like abstract graphs.
Mhm.
Yeah.
Yeah.
The best I like the example that he presented right away, like the quotient. That is a really nice, useful example that you use all the time in algebra. So,
The equivalence relation one.
yep.
Yes.
Because if you think about it, like it makes perfect sense that any map that you have from a set A to like some other set defines an equivalence relation, right? And so it makes sense that okay, well I can map onto it, and then I can map back into that other set from the equivalence classes, right?
Yeah.
So it's kind of like just looking at the image of the set A in Z and calling it its own new set.
Be right back.
So I did get confused with the graphs because it would say like A and B go to A cross B, and then it'd have Z going to.
For the product.
Oh yeah.
Yeah, I didn't know what the
Product
set Z
section?
was. It just seemed random.
It's just any set.
It's just any set.
Yeah, any set equipped with 2 maps.
Okay, I'm back.
I didn't know you left.
And so you had to get what, like a certain map going from the set to A cross B? Is that how it
No,
works?
it's like if you have a set Z and you have any 2 maps, one that goes to A and then one that goes to B, right, starting at Z, then the product always filters Z through it. So Z always has a map to the product and then to A and B.
Okay,
Yeah.
That makes a lot more sense now.
Yep.
I-
And then the same like the other way around with the co-product and the initial objects and stuff.
Okay, that makes a lot more sense.
So when you think about like divisibility, it makes sense that the product is like the GCD, right? So if I have
Right.
anything that divides two numbers, then it has to divide their GCD. And so that's a good example.
I didn't quite understand the empty set example.
Which one was that?
Is that the one in the exercises?
Where is
I
it?
think
No,
so.
the example
It's
the example after the lesson.
Oh, it was the unique initial object in set.
Yeah, like I didn't know what map goes from the empty set to any other set.
Just the map that sends. I think it's like one of those trivial. I forget what they're called. Like it's just because like the empty set is empty, so like pretty much everything about it is true.
Yeah.
Vacuously true statements or something like that.
That makes
Like
sense.
what-
I just didn't
Yeah,
understand how you could map the empty set to another set, and so I guess if the map is like these two sets have the same property, then I could see
Yeah,
it.
there is, for any set like X, there is a unique function with domain empty set and codomain X, which is just, the empty function basically. Because what is a function? It's a subset of like the domain cross the codomain such that for everything in the domain there's a unique element in the codomain such that that pair is in the function.
Yeah,
Right.
I think the set theoretic definition makes a lot more sense in this case than before. Oh, sorry.
I mean, it's always like that. It's just
Well, yeah, I mean, you typically don't like view a function like that, and so it makes more sense to view it like that in this context, is what I mean.
you might not.
Yeah, if you're a freaking brain, but you might not.
No, I mean if you study set
What?
theory, it's an extremely convenient
Well, I don't study set
thing to
theory,
consider
Dakota.
graph. Well, I'm saying some of us do.
Okay, sorry.
Fight.
Well, I didn't mean to impose that everybody would think like that, but
Turn
like a
off
typical
Brookhub, right?
How ignorant, Lane.
Logician versus geometer.
Oh yeah, fuck you. I have a lot of objects that I can actually hit you with. You can just pretend to.
Wow.
I'll throw a basketball in your face.
Uh-huh.
What do? Just tell me I exist? Yeah.
Nice. So how come this was so
Sorry,
freaking
Dakota.
wordy?
What
Like
do you
he
mean?
could- So when he's like, we can have the universal rule be this,
Yeah, but
but
dot.
but we word it in a really crazy long sentence that doesn't use the word universal project is.
Oh, I have a theory about this actually.
That's what made me pissed off about this section.
I
Because
think you
again,
might
you'll
be-
see cases where people just don't describe what they're talking about accurately, and you'll learn how to parse that.
Yeah, that
Yeah,
was
like,
like
fuck
what the
you.
fuck?
Like, fuck this stupid field.
He also used the phrase "dear reader" at some point,
Dear reader,
and I was like, "Oh,
I don't know. I can kind of understand that you might need to parse through words that you're saying, but I don't know. I feel like he should just. I think he's just being lazy or something.
that's kind of yeah."
It was really weird to me. I didn't actually look at the exercises though, because
That's okay.
I was struggling pretty hard to. There's so many freaking terms in this now.
Yeah, this is definitely a section that we might have to reread a bit, but
Because they had
It's-
started putting in terminal.
it just means it's initial
Well,
or final.
that's initial
Yeah.
or final.
Yeah, so I was
No.
reading and I was like, okay, so this is what initial and final is, and then I guess I just missed the definition of terminal, and it goes, so the terminal of this set is, I'm like, the terminal, what happened?
Did you get the fact that if something is say a universal property, then that means it's an object in a category where it is either final or initial.
And not the category that you're talking about necessarily, but
Oh,
possibly
yeah.
some different category
Yes, yeah.
that's related somehow. Like with the case of product, it's a product in C is some final object in C subscript A comma B, where C subscript A comma B is defined in some previous section.
Well, I wasn't listening because I was trying to sideboard.
It's okay.
Oh,
I'm just making sure that the definition of a universal property kind of makes sense. It's like, okay, in some category, this object is initial or final.
Yeah.
Okay. And then Dakota brought up the good point that it's not necessarily the category you're working in at the moment. Like, as long as you can build it in a different category to be initial or final, then it is universal.
Mitch had a good question. So it called it the universal law or something? Universal property? Universal property. But I felt like it never actually defined it. Does that make sense? Like that. Like,
I don't know. I guess I guess I got the definition. Maybe I.
We just talked a lot about final initial. So is the universal universal property the map from?
No, it's the object itself. Like
No, the universal property is the statement that for every object there is a unique other object and other morphism. Really, the morphism is the important one, such that some property holds.
I thought it was the final object itself.
No, the universal property is a statement that that object exists and does what you want it to.
So the property is that the object...
Satisfying the universal property means it has this object and has this morphism.
We said that the construction satisfies a universal property when it may be viewed as a terminal object of a category.
The it, I don't think, refers to the universal property.
Oh, it refers to the construction?
Yes.
Satisfies a universal property and may be viewed as a terminal... Wait, are you sure? Because, like, I'm pretty sure when it says it, you know, I think of, like, a product, and then the product is, like, that whole object in the category. So it's the thing that satisfies the universal property, right?
Lane, it satisfies the universal property. It is not equal to the universal property.
Okay.
Right, there's a difference between being a universal property and satisfying one.
Okay.
A universal property, like, by itself is like some, like, meta thing. Whereas an object or morphism can satisfy a universal property. But this is all really semantics and is not really all that important to what is going on.
Mm-hmm.
Good stuff. Let's see, what else was there? Oh, I don't like how this book refers to, like, okay, so I both like it and dislike it. How he refers to examples in previous sections. Because we're reading these so far apart, I don't remember what they are. So I have to go back, read those, and then come back. Yeah. And I'm like, crap, now I have to go back and forth between these so I know what's going on.
I feel like it'd be easier for you to do that if you had, like, a physical copy. I think it's just because it's online. It's, like, kind of tedious.
Yeah, I agree. So I only dislike it because it feels annoying, but...
I don't want to put effort into learning something. Fuck that.
Yeah, that's exactly right.
Pretty much, to be honest.
That's funny. Did you want to try some of the exercises then? I think these are actually, like, pretty cool. Like, we're finally getting into some, like, neat, beefy exercises.
Sure, let me check real fast to make sure this is actually recording.
Let me get some pizza real fast.
Okay, so it looks like it is recording.
I picture him just, like, making it from scratch and, like,
yeah, Tyler gets out the flour
and like, throws the pizza in the air. Well, like, whoa, Tyler.
I do want to ask if anybody watched the last two videos.
Yes, I did.
I did.
They seemed fine.
Because I worked really hard to make that one come alive.
I think it was...
You, like, Frankensteined it?
Yeah. And it turned out well, in my opinion. And I was pretty happy with that one.
It's good, Austin. Jeez. Yeah, I think it all seemed fine. You must have done really good. Wait, well, damn it. I don't know which one to use now. You must have done really well with the editing because I didn't even notice like a problem with it.
Yeah, so
No,
what
it
I had to
seemed
do
fun.
was I had to chop up the segments to where I was talking and where everyone else was talking and then normalize the levels from there. And so the video was like an hour and 10 minutes. And so I talked a decent amount too, so that's what made it kind of rough.
Okay,
Kind of like a dog.
interesting.
And then the other one, my audio didn't work again, and I just used Tyler's audio. And Tyler is a little wonky in that.
Bit of
Yeah.
a wonk.
Yeah, just a little wonky.
Interesting. Excuse me. Tyler's back.
Tyler's back, so we can talk about the exercises.
Let's go through some of them. Okay. Wait, is Tyler actually back? I heard him, but I don't know if he's like ready.
I'm ready.
Okay, cool.
No, I'm not the one whistling.
Oh.
Dakota. Okay, so the first question says prove that a final object in a category C is initial in the opposite category. That one seems pretty straightforward.
Yes.
You go to C op from C. You just reverse all the arrows, and since there's only like one arrow, so if you take hom of, let's see, I'll call the final object F. So hom of AF, where A is any other object in the set, contains only one element or one morphism. So hom FA in the opposite category will also only contain one arrow, one morphism.
Yes.
Yeah,
This
easy
is starting
peasy.
to feel like topology where we just talk about arrows.
Oh, it will. Don't you fucking worry about
God
that.
fucking damn it. I did not enjoy that class.
let's just move on to the next one.
I
Socks
still
and
got an
sandals.
A in that piece
Socks
of
and sandals. The next one is Austin's question. Prove that the empty set is the unique initial object in set.
Well, so you just... Yeah, how do you prove it if we
You
can't
just show
even
that
know what it
if-
is?
You show that it's the only unique object.
Suppose
the
you
only
had
object.
some other initial
Only
object,
initial.
then because it's initial, then there's a unique map from that thing to any other object. So in particular, take the empty set, the first initial object you started with. Okay, then that other initial object that you have, okay, a morphism in set is, a set function, and the only way you can have a function whose codomain is the empty set is if the domain is the empty set also.
Oh.
Mm-hmm. So there's
Because
two
if your
sets.
domain was non-empty, that element would have to go somewhere, and it can't if your codomain is the empty set.
Nice.
Sweet.
Right, and it's initial for the reasons I think stated before. Let's see. The third exercise says prove that the final objects are unique up to isomorphisms.
You just basically copy down the proof they gave that initial objects are unique up to isomorphism,
Yeah.
and then just reverse some arrows in the right places.
Well, there's only... So if two objects are final, then there's a map going one way and a map going the other way. And there's only one of those in each direction, so they have to be inverses of each other.
It's not that immediate. You have to show that, okay, their composition is a map from an object to itself,
Mm-hmm.
but you know that an arrow from from a terminal object to itself has to be the identity,
Unique?
because there has to
okay.
be only one, and you know that the identity is one, therefore it has to be the identity.
I see. There's a little subtlety there that I missed.
Yeah.
Interesting.
But it's a very, easy subtlety to, yeah.
Okay, so this is a cool one. What are initial and final objects in the category pointed sets? So it says example 3.8, and then it asks if they're unique. what was okay? So pointed sets is you take sets, the category of sets, and then you take a point, and then you look at the co-slice category of that, right? Or am I wrong? Let me scroll up.
I think the objects are pairs, where
Maps
the first thing is
and-
a set, and the second thing is a point in that set.
It says 3.8. Give me 1 second. 3.3.
And the morphisms are exactly the set functions that preserve that extra point.
Okay, call the resulting category set. So it is the co-slice category made from the point. So then you said the objects are the pairs.
Yeah, they state it one way, and then they state it the other way, and the other way is the one that I just said.
Where did they state it the other way? Because I'm just looking at example 3.8.
Yeah, it was in through.
S is any set. The information of object set consists therefore of the choice of node.
Thus, we may denote objects as set star as pairs SS, where S is any set, and S in S is any element of S.
Ah, okay.
Morphism between two such objects is a set function from S to T, such that sigma of S is T.
Okay, cool. So what are the final objects in this category? Shouldn't they just be other points? Or, I guess, like a map and then a point?
I think it's singleton sets.
Yeah, that's
And
what I
then-
mean.
So pairs, where the first coordinate is a singleton set, and the second
Is a
coordinate,
map.
the element in that singleton.
Yeah. The element in that singleton. Yes. Does that make sense?
I think so.
Yep.
Sorry, I'm not listening very well.
That's okay. I have to think a little bit about this.
It's hard to think about this and playing Magic the Gathering.
No, I don't blame you.
Oh God, no!
I didn't think about this in the context of just these like pairs before. Like I answered it with my initial, definition of it, and so I have to like kind of convert everything that I answered about these into the pair thing.
Yeah, I mean, if you want to leave it in the way that you had it before, that's fine.
Yeah.
It's just this way is sort of sounds more natural to me.
Let's see, initial final object. Yeah. So the initial and final objects in this category are the points. So it's the choice of like whatever map you have to those sets, as well as those sets themselves. Like that's the the pair or the set and the singleton.
Hold on.
Let me think of how to phrase this.
Yeah, I think the singletons are like also initial. Like they're both initial and final.
Yeah. Let's see.
Because an arrow from a singleton to any other thing is just the map that sends that single element to whatever the point in that thing is.
Yeah.
Oh, I'm going way too fast.
I thought this was a neat little example, just because it hits home the point that you're not just looking at like the sets themselves, like the singleton sets, but like the singleton as well as whatever map you've chosen for it. So you really are looking at the diagrams presented in this category.
Yeah.
Which is pretty cool. So are these sets unique? Does he mean up to isomorphisms again?
I don't think so.
Okay.
I think you would have said if you meant up to isomorphism, because in 5.2, empty set is the unique, not just unique up to isomorphism, but unique initial object in set. And I don't think that's the case here, because any two singleton sets in this category
are isomorphic. Yeah, so they're unique up to isomorphism, but they're not completely unique.
Right.
Okay. Let's see. Oh god, category consider. Just give me 1 second. Okay, what did it say? So it asked, what are the what are the final objects in the category considered in example 5.3? That was the equivalence class category, right?
I believe so.
Yeah,
Quotient.
so
Yeah.
the quotient.
So what are those initial objects?
The initial objects of the equivalent set? Or the equivalence category?
Yeah, so I had to take a little bit to like understand what category he was even talking about in this one, but I think it's the co-slice category of A. So like you have some category C, and then you take A, an object in there, and then you build the co-slice category, and then the what was it? The final objects. Yeah, sorry. The initial objects in this category then are the equivalence class things, like the A mod its equivalence relation defined by that.
That's what I was thinking, is that it'd just be the equivalence sets themselves, right? That's what you just said?
Oh, I think I read the question wrong. So those are the initial objects.
Yeah.
The question asks what the final objects are. So like...
Oh.
Yeah, sorry, my bad.
Okay. Is there a reason they wouldn't be just the singletons that it's leading to then?
I thought that's actually what I thought too. Like the singletons as well as like some map to them, like that pair.
Yeah, like what else could it be? Isn't that the only things in the sets?
Hold on, I'm going to look at this example now.
Or is there just no final object because... No, that can't
No.
be right.
No, I think it'd just be the singleton ones, right? Because like okay, let me think about this for a second. So there's at least a singleton in this category, like a singleton and a map from A to that singleton, right? So that's at least one final object. So no, I think it's just the pair, like the map and the singleton.
What do you think, Dakota?
Example 5.3?
Dakota's just playing Oblivion. Kerbal?
No.
Oh, never mind. Kerbal Space Program.
I'm screen sharing, Lane. Can't you see? It's also not letting me, focus only on Kerbal. I tell it to focus only on Kerbal, and it just defaults to showing my entire screen.
It's like, no.
Huh.
Change windows. Gesundheit.
Thank you.
Go to application window. Click Kerbal Space Program. Share, and then nothing changes.
Well, what do you think of the problem?
Oh, sorry.
No, it's okay. I understand.
5.3. Quotients, right?
Yep.
Okay.
So, I thought the definition said that the initials and finals had to be unique, or is that just the map had to be
Like
unique?
up to isomorphism. So you could have multiple initial and final objects, but they're all isomorphic.
Okay.
There's always one map. So if something is a final object, right, then there's only ever one map that goes from some other object to that final object, right? So Hom like AF would always be just one morphism. So it does matter like the direction that the maps are going.
Okay.
Yeah, I don't know. That was something that confused me about these things for a while, because I was thinking like, oh, well, if there's an isomorphism between them, wouldn't that mean there's more than one map? But it's like, no, there's one map going to it and then one map going from it.
Okay. Because this problem seems almost baby tier if it's just the fucking other thing in the set.
Well, there's a lot of things in the set, right? But or there's a lot of things in the category, but this is just, it makes sense. I don't know if it's. Is Dakota? Is he dead?
I'm thinking about it.
Oh, okay, sorry.
Do you have any ideas, Tyler?
Oh no.
we moved this date for you, Tyler.
Don't give him shit. This was
I'm
kind of a rough section.
No, it's okay. Why aren't you just super supreme category theory wizard number 5? Like, what the heck, Tyler?
Number 5.
Yeah. The first being Norm J. Wildberger, and then...
Norm Wildberger is so fucking funny. God.
Oh, one of my grad school friends, went to undergrad with him as a professor at, University of New South Wales.
Oh my god.
And he's he gave us his textbook for free because he couldn't get enough people to buy it. I still go back and look to it whenever I want to laugh, he said.
Oh my god.
What?
Norm J. Wildberger is an ultra-finitist, so he doesn't really believe in infinities.
Huh.
Yeah.
He proved the twin prime conjecture for all the numbers that exist.
God fucking damn it. That was so embarrassing.
Not even sure if I understand what that means.
Nothing.
Do you just assume that they were finitely
Just Austin, all you have to do is go watch every single video on NJ Wildberger's channel, and you'll understand the memery.
I will say, it's unfortunate that he has that, weird view, because a lot of his other videos are actually pretty good.
No, his videos are fine if he doesn't go into the ultra finitist stuff. I watch him all the time for some. He has some interesting videos, and he's published a lot in harmonic analysis and things like this. So he's a good mathematician. He's just what the fuck? He just has really, really, surprisingly bad arguments that, infinite sets don't exist. It's just... But his YouTube channel is actually fine, otherwise.
Yeah. Yeah, I'd agree with that. His algebraic geometry stuff is really cool.
Interesting.
You should check out some of his stuff.
Well,
he taught a class of rational trigonometry where they don't ever use anything that isn't an irrational number. And he has a book about it, and people are like, wow, this is worthless.
His book is logically valid, but then people are like, isn't this just equivalent to trigonometry? Here, this thing you define right here is just the sine squared. What's the deal?
It gets rid of all problems.
It's I define the spread instead of the sine and cosine. It's this is just the sine squared norm. It's not. And in fact, the sine squared is like a generalization of what you're doing anyways.
Norm. Good old Norm J. Wildberg.
It's not that his book is incorrect. People are just looking at it like, okay, this is just like rephrasing geometry or trigonometry.
No, I mean, that's like, so it's like, okay, we'll just not have irrational numbers. It's like, okay, so you just have an entire section that you're not even going to be using. It's like half trigonometry or something. You get half the value from it than a regular trig class because you don't consider like things that are, important.
It's so weird that he became a mathematician. So mathematicians are usually like extra especially rigorous in their argumentation. Mm-hmm. But then he'll say like, oh, there's a finite number of integers because there's not even like enough electrons to count. The largest integer is like the number of elementary particles. And we're like, that's like an open empirical question as to whether there are actually a finite number of them. Like, you can't just hand wave like that. It's much more useful to have the abstraction. And so, who says in the first instance that that's what integers are? Like, it's so, like, I don't know. He's a perplexing guy.
Yeah.
That's for sure.
Because most of his channel is actually pretty good videos, but then some of his stuff is just like, what? It's not a good argument. That sucks.
I like it. For those unaware, I like to look at weird theories like that. Like, I've been really into flat Earth recently.
Oh, wait, hey, yeah, me too.
Yeah, that's been pretty fun.
God.
I don't think I've talked about it with Tyler, but I've talked about it with, I know, Mitch and Lane.
Oh, you told me, yeah.
Okay.
I found them boring after a while.
It's just funny hearing their arguments.
Dude, they're so great, because it's like, just look. You don't see curvature, do you? So it must not be real. Like, oh, okay.
So one of my favorite infographs comes from flat earthers, and it shows a sphere, and it's like, okay, if the Earth was spherical, and it shows a triangle on the surface of a sphere, so it's not like a Euclidean triangle. It's like a sphere. Yeah, it's like a hyperbolic triangle, and so it has 3 90-degree angles. And they're like, see, the Pythagorean theorem isn't true on a sphere, so Earth can't be spherical. And I was just like, are you arguing that spheres aren't real? Because this has nothing to do with the Earth in particular.
Well, we were discussing the fact that there's like sects of flat earthers.
What?
There's like flat earthers that think different things.
I thought you said sex, and I was like, is this like a dating website between?
Yeah, I thought so too.
Sex with
Like,
a
do they
T.
not get laid or what? Just because they're flat Earth.
Yeah, because of the spotlight sun and the...
I also I like the Mandela effect too, like all those weird conspiracies. That's a good one.
We're in the Berenstain universe.
Well, the person that came
just
up with
resonated.
it was like... Yeah, the person that first published something about it was like, it's because we're constantly flipping back and forth between
universes.
The universes.
They're just colliding with each other, and then, that's why my memory is so shitty.
Yeah.
Like super Mendeleev effect.
Yeah. It's like, did Mandela die in prison? No? Oh, universes.
Yeah.
Yep.
I was really into that.
Oh, that was the other universe. Oops.
I was super into that too. I looked up a bunch of those. I don't remember any of them though.
Yeah.
Except for that one, the main one.
One of the creepiest ones is, I remember with the Disney castle animation, that Tinkerbell, or it was some Walt Disney logo animation that would appear if you had on VHS any of the classic Disney. Tinkerbell would come put the star on top of the Disney eye or something, or dot the Disney eye with her wand.
Yeah.
But apparently that didn't happen ever.
What? What? No.
Yeah,
That totally happened. That's
apparently.
stupid. Oh my god.
Yeah, that one freaked me out because I was like, that totally happened. And then I went to a compilation of like Disney classic intros, and Tinkerbell was not in any of them.
I thought
What?
the stock, like the line that goes through the tallest tower of the castle.
Yeah, doesn't she draw
I
that?
thought that was Tinkerbell, or supposed to
No.
be Tinkerbell.
I thought so. I think my favorite.
Oh,
is
I know what you're talking. The arc. That's not what
Yeah.
I'm talking about. I'm talking about like her actual Peter Pan character.
Oh,
Animated
okay.
comes out and then tings like the dot on top of the eye of Disney and then it went away. And I was like, oh yeah, I remember that. And then
well, I remember that
it was
happening
like-
too. So
I remember her
It was
doing
like-
something. I don't remember it being on the logo.
Where?
well, she
uh,
is a character. I think she's a character.
She is a Disney.
I think
Tinkerbell
she
is a
Tinkerbell sure
character.
is a card.
Yeah. Like,
Okay, not completely insane. She's a blonde lady in a green dress.
No, Tinkerbell. is
if I
really
looked on the internet and like if I looked on the internet and literally couldn't find the Disney Tinkerbell, I'd just be like, okay, we're literally
Tinkerbell
like
just doesn't exist.
like Berenstain Universe theory is literally true.
Universe theory. That's the Mandela effect.
Oh, that was funny.
So Dakota, did you get a chance to look at that?
Oh shit, I got distracted.
Okay, you know what? Austin and I are right. It's just okay. We're next question.
Yeah, let's...
That's
Some
fine.
questions are, I think, like,
Better
cursed.
left unsaid.
Okay, here's a good one. So consider the category corresponding to endowing the positive integers with the divisibility relation, right? So there's an arrow that points from a number to another number if, say, I think it's if that number divides the other number. So A points to B if A divides B.
Yeah.
Okay. Then there's exactly one morphism, D to M, in this category if and only if D divides M without remainder. Oh yeah, they say that right after.
Basically what you just said.
Show that this category has products and co-products, and then what are their conventional names? This one was cool.
Yeah.
What do you think?
What question are you guys on?
5.6.
Oh. Consider the category corresponding to endowing, as an example 3-3, the set Z plus of positive integers with the divisibility relation. Thus there's exactly one morphism D to M in this category if and only if D divides M without remainder. There's no morphism between D and M otherwise. Show that this category has products and co-products. What are their conventional names? So, like, what's C? So, in order to find products and co-products, you need to find, like, C sub A, B. Or...
Mhm. So it's like let's do the which one is the product with projective maps? Is that C to the C upper AB?
I guess. So it's something that divides something else that then divides. Oh, is it like the number...
The number 5?
Well, I was thinking maybe it's like...
Sorry.
Maybe it's the least common denominator between the two?
Or close, actually. It's the least common divisor. Or, sorry, GCD.
Greatest common divisor.
Yeah,
Greatest
yeah,
common divisor. Oh,
not least common. That'd always be 1. My bad.
Yeah, greatest common divisor.
Yeah.
And then the co-product is the least common denominator.
Least common multiple.
Oh yeah, I'm retarded. I forgot.
Tyler, me too. Don't worry. This is
I forget it. That's like second grade. Whatever.
yeah. They're like, oh yeah. Do you remember that terminal object? and the class is like, yeah, GCD.
That's one of my quantum professor's favorite jokes. He's always like, oh, and of course we know this from kindergarten. Like, oh yeah.
Yeah,
Like,
the fine instruction.
Yeah, it's like, of course.
Like, oh, okay. Yeah.
I of course know the Zeeman effect from kindergarten.
Tyler and I used to joke like that all the time. Like, I learned this when I was in first grade, you idiot.
You don't know what a universal property is? What are you, like, 4? Loser.
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 Babby's first co-product.
I think one of my students said that to another student in a recitation.
Babby's
They're trying to
first
take-
co-product.
No, they were trying to take derivatives, and he's like, what are you, a baby? You don't know how to take a derivative? And I was like, Tom,
God, I didn't know
seriously,
Jesse
calm
was
down.
here.
That's too mean.
Don't be
He
so mean
takes
to
those pretty
Jesse.
seriously. We should make
I
fun
know.
of him.
He's- yeah.
You mom. I'm not kidding.
But yeah, that one's cool. I think the thing that I think is really interesting about it is that there's the condition that needs to be satisfied that for any other, like, what is it? So if any number divides both A and B, then it has to divide their GCD. So that divisibility relation is like unique in some way because there's only one, morphism in this category that goes from that other number to the GCD and stuff.
Mhm.
That was something that I had to spend a while thinking about to, like, I don't know, it just seems kind of weird, but pretty neat.
It's also completely irrelevant to what we're talking about, but it's
What?
worth mentioning
Thanks a lot,
that...
Dakota. Jeez.
No, the thing that is not relevant is the thing I'm about to say.
Oh, okay, okay.
So whenever you have a category where there's only one morphism, or at most one morphism from one thing to another thing,
Mhm.
then all the morphisms are epimorphisms and monomorphisms.
Wait,
right.
so in this category, everything is an epi and a
Yes, every morphism is both epi and mono, I think.
Interesting.
Hmm.
Is that right?
So it's a groupoid?
Yeah,
not
actually, I
necessarily. 'Cause
Oh,
just because there is something is an epimorphism and a monomorphism, that doesn't necessarily make it an isomorphism.
Oh,
Okay.
yeah.
okay, you're right. But that makes sense, right? Like if so if A divides B and B divides C, then obviously A divides C. Right? So you always have that relation with the morphisms.
Yeah, so you do have associativity. Yeah.
No, I'm thinking like okay, what is it? So for there to be a map, okay, it's A divides B. God damn it! I actually have to. I'd have to draw up like some maps to think about what I'm trying to say. So never mind. Next question.
Hold on, I'll be right back.
Is he coming over to my place?
Yeah, he's gonna come over and draw it for you.
He's like, okay, baby, you don't understand these maps. Like, I'm sorry, Dakota. Well, what it like if I have like A and B as objects, so like A divides B, and then say like what, like B divides C and B divides D, then A divides C and A divides D, right? Like that would
Yeah.
be one of those morphisms. That's what I meant to say, I think.
Oh, well, it's just transitivity.
Okay, I'm back.
Isn't that what he was saying earlier? Isn't that like
Well,
automatic between categories? Is the object have to be transitive?
that's
Wait, so I missed a bunch of this. Say this again.
We're trying
okay.
we're still talking about what you just said.
Yeah,
Oh.
what I meant to say is in this category you have like, so if A divides B, okay, and B divides C and B divides D, then A has to divide C and D, and that would be like epimorphic.
Yes.
That'd be like epimorphic, right? Or that's monomorphic. I think that's monomorphic.
So monomorphic just means it's left cancelable, right?
Yeah, so
right
that I think I set up a system that is left cancelable. I haven't actually written this down yet, but
I don't think you need to like use this specific category. Yes, it's a monomorphism. F is a monomorphism if F composed with alpha prime and equals F composed with alpha double prime implies alpha prime equals alpha double prime.
yeah.
BRB.
Okay. If that happens for all morphisms, alpha prime and alpha double prime, in HOM ZA, where A is the domain of F and Z is just anything.
Yeah.
If you have any alpha prime and alpha double prime in like HOM ZA, they have to be equal in this category because there's at most one morphism between any two objects.
Yeah.
And the one's the identity?
Yeah, right?
Not if the two objects aren't equal, but
But isn't there only one? Wait. Okay.
I
think that's fine.
think I'm a little confused because I think redo exercise 2.9, this time using proposition 5.4.
oh, we're just moving on? Okay.
Yeah, well, okay, so I wouldn't mind trying to understand it, but I really think I just write it down and then, like, ask you about it afterward, because I was pretty sure what I said was exactly, like, the scenario. I was just trying to understand what, like, a monomorphism was in this category. But it's not a big deal. I don't
A
want to...
monomorphism in this category is just any morphism.
Yeah.
Because every morphism is mono.
Yeah. I agree.
The hell does 2.9 say?
I don't know. So,
back up.
I'll be back. Never.
Show that if A prime isomorphic to A double prime and B prime isomorphic to B double prime, and further A prime intersect B prime. Oh, we're in set. Okay. A prime intersect B prime and A double prime intersect B double prime are both empty. And A prime union B prime is isomorphic to A double prime union B double. Include that the operation A amalg B
Where is it? Oh,
is
there it
well
is.
defined up to isomorphism. Okay.
Two disjoints, that's A and B, isomorphic to A and B respectively.
Proposition 5.4. Ah, okay.
Hi, Grandpa.
So for 5.7, you just have to show that A prime union B prime and A double prime union B double prime are both terminal objects.
They're the disjoint union?
Yes.
Yeah,
The disjoint union.
but they're terminal in the C lower AB, right?
I think so. Or initial, or one of them.
Those ones should be initial if they're the disjoint union, because the product, I believe, is the final in the C upper AB. Yeah.
I believe it.
So you want to show that any two objects that are initial are isomorphic? Or am I reading the wrong proposition?
Well, we're using that proposition.
Oh, to prove... Okay, I see what you're saying. Oh, okay.
So if you can show that both of those things are final or initial, then they must be isomorphic by proposition 5.4. Whereas the original statement of exercise 2.9 was show that these things are isomorphic, like by hand, basically. But we don't have to do that anymore because it just falls out of our Dumaflachi.
Yeah. Just copy the estimate.
Dumaflachi?
Yeah.
What's Dumaflachi?
It's like, like a
They define it in this
thingamajig, or like
What?
like who's the what's it?
Dakota, you can't just like...
Like the
Oh my
candy
God.
bar?
I think you're thinking of a whatchamacallit.
no. Dakota.
Yeah, it's just a placeholder word for when
Can
you don't
you-
want to think of the word that you actually mean to say.
Can you define, like, please just, like, make a mathematical object and call it a who'sma what's it or whatever you said?
Dumaflachi.
A Dumaflachi.
Dumaflachi, I'm sorry.
Please make that a real mathematical thing, like, rigorously.
Make Dumaflachi a real thing. Gotcha.
We call it a Dumaflachi, like a thingamajig.
From a whatchamacallit.
And everybody's like, what the fuck?
Honestly, that is what category theory feels like sometimes.
Yeah, I
All
think
this notation is so stupid.
it was really annoying. So I had a lot of fun, like, thinking about and writing down some of these exercises, but talking about it right now is, like, probably the hardest thing I've ever had to do. Because it's
Why
like,
do you think
oh
I
yeah,
went and got a beer?
oh, you, like, heard me talking about it and then you got a beer.
No, I was like, I'm going to beer class tonight. Might as well, do some studying before class.
Oh, I
Your
see.
class?
Yeah, so we go to this bar in downtown Champaign, pay
These
$10.
beers are isomorphic.
You get 10 beers, and you can, like, you sample each of them, and Virgil, the guy in charge,
Mhm.
this guy who works at a local brewery, and he has an amazing beard, and he just talks about, like, how to, like, critique beer, and, like, what makes some beers, like, different or interesting.
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 Prove that these two beers are isomorphic in my stomach. I drank both of them. QED.
All right, what the fuck are we doing? 5 point.
I don't know. I thought we were gonna be done a little earlier, to be honest, because what is it? That one thing is tonight, trivia.
Oh yeah.
Rhombus, and it's the first night in a long time that I'd be able to actually go to Rhombus trivia.
Well, we can
Wait,
end
it's
if you want.
8 p.m. right now.
We can end because I'm not paying any attention anymore.
I had a lot of fun talking about Norm J. Wildberg. He's a cool guy.
So I guess what we should do is assign the rest of the exercises as homework.
How about do you want to, like, each do a problem and then present it next?
Oh, fuck no.
I don't. I can't do that.
Oh, really? Because, like, I was gonna say that'd probably be a little easier to follow than just talking out loud about this stuff.
I could work on a problem.
I'll work on a problem.
I wouldn't mind doing that.
I can't.
Okay, which
I'll do
problems
it.
do you
I'll
guys
do
have?
it when I finish my salts.
Just
That's
assign
fine,
me one
never.
since I don't have the book open.
Austin, do 5.9.
5.
Or skip 5.8. Dakota, do 5.8.
I'll do 5.8.
Yeah, Tyler, do 5.10.
I'm just gonna type this into Discord so I remember later.
Fine.
I'll do 5.11. And Mitch, you get the last exercise.
Mitch isn't gonna do it.
Oh, well, too bad. Then he gets an F.
Good.
Poor Mitch.
That's fine with me.
You failed book club. Seppi'd be so disappointed in you, Mitch.
And then next we get to start groups.
now we can actually like start using it, which is nice.
Yeah. We can get to joke 1.1.
I'm excited to use the universal properties finally to actually start talking about like the kernels of like objects and stuff.
Yeah.
Because it's pretty cool. Just the quotient of like a group by its kernel of a map is some initial object in its co-slice category, which is neat. Okay.
Okay, cool. Here's
Break.
Bookies coming at you next week. Bye.
Well, bye.
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 Bye.